We are now on part 2 of lesson 5, motion one dimension, free fall. So for now, we are now going to try to solve several problems involving free falling bodies. For this, we're going to accomplish our subtopics 2, 3, 4, and 5. So this would be quite long. Have your pens and papers ready, and let's begin. Okay, so we are now given our first problem here. Free fall finding velocity. Let's read. A student conducts a free fall experiment while on a school balcony 20 meters above the ground. The student drops a heavy ball. What is the final velocity of the ball as it hits the ground from the instant it is released? Okay, so how do we attack problems like this? Now, it's a good practice to illustrate it first. And that's what I'm going to do. So we have here the balcony example, and then there's the student at the top, drops the ball. And so illustrating it gives us some kind of a storyline on what's happening on our problem. Okay, the student drops the ball from certain height. And according to this, the height is actually 20 meters. So that's important. We'll write it down. The height in which the ball fall is actually 20 meters. Okay, so that's it. Let's now try to write our given. Of course, this one would be our given, that is the displacement. And it has initial and it has final. Y initial or Y not would be 20 meters. Why is it 20 meters? Since dun nag-start yung pag-fall ng ating ball. Meanwhile, our Y final should be 0 meters. Since if the ball fall from that height, dito siya malalaglag, that's 0 meters in terms of Cartesian plane or our coordinate system. How about our initial velocity? Do we have our initial velocity? I think yes. Our initial velocity in the y-axis, is actually 0 meters per second. Why is that 0? Because according to our story here, we or the student drops. So when we say drops, hindi niya pinukol. Pag hindi niya pinukol, ibig sabihin nun, the student did not give any velocity to the ball. Binitawan niya lang. Meanwhile, we're asked to find the final velocity. So we're searching for our final velocity in the y-axis. I think that's it. However, this is a free fall experiment, meaning we have our gravity. And our gravity is, of course, negative 9.8 meters per second square. Again, kindly remember that when it's a free fall problem set, gravity should be given kahit hindi siya banggitin dito. Okay, those are given. Next is we'll now try to find what formula are we going to use. Let's try to analyze. For our first equation here, seems good because we are trying to search for the final velocity. Ito yung ating hinahanap, and we are given initial velocity and gravity. However, we don't have time. So, time is not given. So, iwan muna natin siya. Equation number 2, can we use this? I don't think so. We can't use equation number 2 since if we're searching for final velocity, there's no final velocity in this formula. Let's now look at equation number 3. Equation number 3, good because final velocity is present there. Initial is also present. gravity is present, and the the position is also given, that is yi and yf. So I think the equation that we have to use is equation number 3 instead of equation number 1. Okay, so we'll write down equation number 3 here. So we have here vfy squared is equals to voy, rather viy. Again, pareho lang yon. Not and I means the same thing. Plus 2g, then yf minus yi, or y minus y naught. That's the same thing there. Okay, our only concern here is that we're searching for the final velocity, but this is final velocity squared. So we have to isolate the final velocity, and for us to do that, we have to square both sides, right? Square both sides. But before I do that, we can cancel out some parts here. For example, our initial velocity is 0, which means this would be 0 squared, so that would be 0. So pwede na natin siyang tanggalin. And that would give us vfy squared is equal to 2g yf minus yi. Removing the square here, I'm going to square root both sides. Cancel, cancel. Then my formula will now be vfy is equal to the square root of 2g yf minus yi. Okay, let's look at our equation. Do we have our g? Yes, that's negative 9.8. Do we have a yf? Yes, that's 0 meters. Yi, that is 20 meters. Okay, let's plug in our values. Square root of 2, negative 9.8 meters per second squared. That will be 0. Yf natin is 0. And our yi is 20 meters. I did not write anymore the units, so we're going to have here a cleaner equation. Okay, let's move it here. So from here, we're going to have, if you try to compute that, get your calculators. Square root of 0 minus 20. Okay, the answer here would be 19.79. Okay, so we have 9.798. So I think it's safe to say that it's 19.80 meters per second, since we're searching for the final velocity. Now, this is a square root, which means we have actually two answers: a positive 19.80 meters per second and a negative 9.80 meters per second. So what does a positive 19.80 meters per second mean, and what does a negative 19.80 meters per second mean? Just like our previous example, a positive velocity here means the velocity is moving upward. Meanwhile, a negative velocity is moving downward. And as per our example here, since the ball fall from a certain height, it means that the velocity is moving downward. So the final answer should be the negative 19.80 meters per second. Questions? Let's proceed to our next problem. Okay, for our next problem, let's read. A student conducts a free fall experiment while on a school balcony 20 meters above the ground. If the student drops a heavy ball, what is the time it took the ball before it hits the ground from the instant it is released? So this time, instead of searching for the final velocity, we are tasked to search for the the time it took the ball. So this concept in free fall experiment, or in free fall problem solving, it's called the time in the air. And this is actually very, very important. So Please kindly focus. Okay, same as the last time, let's illustrate that one by drawing here the balcony of the school, then the student there. Then it drops the ball from that point and until it reaches a certain height there. Okay, so this is still 20 meters. The height nung paglaglag ng ball, that's still 20 meters. Let's write our given. So our given would be the initial velocity would still be 0 meters per second since, again, hindi niya naman pinukol, binitawan niya lang. So our initial velocity would be 0 meters per second. We don't have our final velocity. How about our position? Our initial position would be 20 meters since it started at this height. That's 20 meters. Our final position would be 0 meters because that will be the time it hits the ground. And of course, gravity is also given to us. It's negative 9.8 meters per second is squared. Okay, so those are our given. Let's now analyze our formula. What formula is applicable? Again, we're searching for time. So obviously, the third formula won't be useful to us because there's no time in that formula. We only have here the first and the second. Meron silang time dito. Let's analyze the first one. We don't have final velocity, so medyo tagilid na gagamitin natin siya. But let's leave it for now. Let's look at equation number 2. For equation number 2, we have here the y final, y initial that's given. Initial velocity is also given. Time, we are searching for that. Gravity is given. So which means that number 2, equation number 2 is the most applicable for our problem here. So let's write it down. Here, we have the y final is equal to y initial. Again, I'm changing here my units, but yf and then yi, pareho lang yan, plus initial velocity in the y-axis multiplied by time plus 1/2 gravity time squared. Okay, before we move on and plug our values here, let's like look if there are certain parts of the formula here that we can cancel out. Okay, so from here, our y final, which is this part here, is actually 0, which means we can cancel that out. Our y initial won't be 0, that would be 20 meters. Our initial velocity is 0 since it drops the ball, so that would be 0. And gravity is given, we are searching for A. Our new formula will now be, of course, hindi naman pwedeng may kulang dito. So what I'm going to do is move this here. That's yi plus 1/2 gt squared. And then I'm going to leave the 0 here para hindi tayo malito in a while. Okay? I'm going to plug in now my value kasi hindi naman pwedeng walang value again dito inside equation na to. So yi is of course 20 meters. That's 20. I'm going to leave out the units, so we're going to have here a simpler, cleaner presentation of the solution. Plus 1/2. G is of course negative 9.9. Negative 9.8 rather. Multiplied by t squared. Again, what is our goal here? Our goal here is to isolate our t because that is our time in the air. So ito yung gusto nating ihiwalay. Okay, so let's simplify this first. So that will be 0, 20, multiply 1/2 multiplied by negative 9.8. We're going to have negative 4.9 t squared. Okay, so again, we want to isolate t. What I want to do now is to move this part here into the others. I want to move this part here into the other side of the equation, giving me positive 4.9 t squared is equal to positive 20. Okay, And then I'll divide both sides by 4.9 para matanggal ko to dito. And I'm going to have t squared is equal to 20 over 4.9. Again, I need t or time in the air and not time squared for me to eliminate this squared value here. I'm going to square root both sides. Cancel, cancel. And now my formula will be t is equal to the square root of 20 over 4.9. Okay, plug that in your calculator. You're going to have 2.02. And since this is square root, it means that we actually have two answers, a positive 2.02 and a negative 2.02. So let's analyze what do we mean by a positive 2.02 and a negative 2.02. A positive 2.02 means it started here kung saan drinap yung ball, going kung saan papunta yung ball. So that's the positive 2.02. Meanwhile, a negative 2.02 means that our story started here at the ground and it should move papunta doon sa may upward. So ground up, which means that since our story started from here at the top going to the ground, the more applicable answer would be a positive 2.02. So our final answer is time in the air is 2.02, which means that from the moment na binitawan ng student yung bola dito, it took just about 2.02 seconds for it to hit the ground. Any questions? None? Let's proceed. Okay, for our problem number 3, we have here still the same situation. We have a student that conducts a free fall experiment while on the school balcony 20 meters above the ground. The student throws a heavy ball upward at a velocity of 15 meters per second. What's the time it took the ball before it hits the ground from the instant it's released, and what is the ball's final velocity? And as you can see here, it looked like the same problem, but it's not. We have here throws a heavy ball upward. So this time, the student gives it some kind of velocity that is 15 meters per second. Okay, so that's the difference from the previous story. Now, how do we illustrate that? We still have here the balcony, and we have there the student. Now, instead of just dropping, ang ginawa ng student is that he or she actually throws the ball upward. So, binato niyang ganon. Then, of course, from there, it will drop pababa. Okay, so that's our story now. Hindi na siya diretso. So the student gives it an initial velocity of 15 meters per second. Okay, and of course, still the height of this building is 20 meters. Okay, we are searching for the time it took the ball, that is time in the air, and the final velocity. So we are also searching for the final velocity. So bago siya huminto dito, ano yung kanyang bilis before it hits the ground. Okay, let's write down our given. Actually, our given is same as last time, except this time our initial velocity is actually 15 meters per second. Our final velocity is 0 meters per second. We don't have our initial position. Actually, we do in this part here. Our initial position is 20 meters. Our final position is 0 meters for the whole story. So why did I emphasize that it's for the whole story? Because our story here is actually divided into two. The first one is when it goes up, and then the other one is if it goes down there. Okay? So how do we search for the time in the air? Just like last time, usually what we use is equation number 2 to search for time in the air. Okay, let's write it down. Let's search for time in the air. Y is equal to Y final is equal to Y initial plus the initial velocity on the y-axis multiplied by the time plus 1/2 gravity time squared. Okay, so let's write down if there are parts here that we can cancel, or let's just observe. What is our y final? Our y final here would be 0 meters because we're talking about time in the air, meaning nung pagkapukol niya starting this one hanggang pagdating sa dulo, saan siya napunta? That is 0 meters. So let's write down as 0. What is our initial position? Our initial position is still be 20 meters plus our initial velocity. So this time it's not 0, it is 15 meters per second. So let's write it down as 15 multiplied by t because we're trying to search for t plus 1/2 negative 9.8 t squared. Okay, so from here, let me just multiply this one. So we're going to have 0 is equal to 20 plus 15t plus, minus 4.9 t squared. And if you're going to recall, going to observe this one, this is actually a quadratic equation, right? Now, to arrange this quadratic equation, we are to use the quadratic formula later. If you can't recall the quadratic formula, we're going to write it down. But let me just rearrange this one. And I want this to be a positive value. So for me to do that, I'm going to multiply both sides by -1. So this would still be 0. And following the quadratic formula, this would be negative, negative. This will now be a positive 4.9 t squared. Negative, positive, that will be negative 15t. Negative, positive, that will now be a negative 20. Okay, I hope you can recall that's a squared, b, and then c. Okay, so let's write down our quadratic formula. That would be searching for t is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, this is the quadratic formula. Just kindly remember that. Now, the quadratic formula is, what we're going to do now is, using our quadratic equation here, this 4.9t squared will be our a, this 15t will be our b, and this 20 will be our c. Right? So, eto mga values na to, ito yung ipa-plug natin dito. Let's do that. So, that will be t is equal to negative b multiplied by negative 15. They're going to have their positive 15, negative, negative, plus or minus the square root of b squared, so that's still 15, 15 squared, minus 4, a is 4.9, so that's 4.9, multiplied by c, and our c is 20, so that's 20 here. Okay, this is actually negative 20 over 2a, and our a is 4.9. This is now our equation for finding time in the air using the quadratic equation. Let's move it here. Let me simplify this. Let me simplify this part first. And I'm going to have there t is equal to 15 plus or minus the square root of, let me plug that in my calculator. You're going to have 617 over 2 multiplied by 4.9. You're going to have, of course, 9.8. Okay, so the square root of 617 is will give you still two types of answer. That can be 15. You compute the square root of 617, that will be 24.8, which means that you're going to have 15 plus 24.8 over 9.8, and that will give you a positive answer. Also, if you're to use the other one, the minus, that will be 15 minus 24.8, and of course that will give you a negative answer. Okay, so you have two answers here. For this one, if you try to compute for this one, you're going to have 4.06 seconds. For this one, if you try to compute this one, that will give you a negative 1.0 seconds. Okay, so which is more applicable? Now, when you look at this one, again, we started here, moves up throughout our story. How about the negative 1.0? The negative 1.0 means that is the time if you started from this point papunta doon. So that is what negative 1.00 means. Now, in our story here, it makes sense that it started here and then we go from this point up to the ground. So our time in the air would be 4.06 seconds. Okay, that's how you do it. Now, we'll now try to search for the final velocity. And if you're going to look at here, it will be easier for us since we already have our time or time in the air. And we are to use the first formula here since it's searching for the final velocity. Let's write it down. Vfy is equal to the initial velocity y plus gravity time. And let's just plug in our value. Our initial velocity is, of course, 15 meters per second. That's 15 plus negative 9.8 multiplied by our time in the air, that is 4.06. Just plug that in your calculator. 15 plus negative 9.8, 4.06. You're going to have negative 24.788. That is 24.80 meters per second. Okay, that is our final answer for the final velocity. Should it be negative? Yes, because according to our story here, by the time ito papunta siya ng kanyang final velocity, it's going downward, and downward means negative in terms of velocity. And that's how you do it. Okay, so this is our final problem. We are now to search for the maximum height. We still have the same problem set as example number 3. Let's illustrate that. We have here the balcony. We have here the student that throws the ball upward. And it reached a certain height there before it, of course, it should fall down due to gravity. Our question now is the maximum height. So what do we mean when we say maximum height? If the balcony is 20 meters, this one is 20 meters. And if you throw the ball, you're going to have an additional y. Okay? So, which means that the height maximum is equal to the height of the school balcony, which is 20 meters, plus delta y, which is the y on this situation here, nung inangat pagkapukol. Okay? Let's write down our given para lang makita natin if there are something useful there. We're given our initial velocity, that is 15 meters per second. We're just searching for the situation here, which means we have to analyze. For example, I have here the ball and then I throw it upward. I'm going to have here an initial velocity of 15 meters per second. Question now is, what is my final velocity in this situation? Okay, so my final velocity is, remember that if you try to imagine, if you throw a ball upward, there will be a time it will momentarily stop before it starts accelerating downward. And from the keyword there, it momentarily stop, which means that the final velocity for this situation only, this delta y situation, is actually 0 meters per second. Okay, and of course our y initial is 20 meters. This the value there, that is 20 meters here. We don't need yung height niya pababa, we don't need that, so we don't write it down. And our gravity is of course negative 9.8. That's our given for this situation. Okay, let's now analyze our formula. Again, remember that we are searching for the delta y. This one, we're searching for that one. Looking at equation number 1 here, I can't use this because there's no delta y, so automatically we can cancel that out. Equation number 2, there's a delta y here. There's a delta y present here, but we don't have time for this problem set. But it's possible that we can use that, but let's check first if there's a more applicable situation. That being said, let's analyze equation number 3. So for equation number 3, we have final velocity squared here, initial velocity squared, plus gravity delta y. Okay, do we have final velocity given? Yes, that's 0 meters. Initial velocity, yes, that's 15. Do we have gravity? Obviously, meters per second squared. And we're searching for delta y, and I think equation number 3 is the most applicable. So let's just write it down here. Squared is equal to initial velocity squared plus 2g delta y. Let me write this one as delta y. Okay. So let's look if we can cancel out some parts here. Our final velocity is 0 according to this one, so we can cancel that out. I'm now going to transfer viy squared here in the other side of the equation, and I'm going to have there negative viy squared is equal to 2g delta y. Again, kindly remember that what we want to do is we want to isolate delta y. That's what we want to do. We want to isolate delta y. Okay, what is our vi? That is 15. So that would be negative 15 squared is equal to 2g. Our g is of course negative 9.8 delta y. Okay. So we want to isolate delta y, so we can divide both sides by 2, negative 9.8, so we can cancel this out. This will be 2, negative 9.8. Our formula now for searching for delta y is negative 15 squared 2 multiplied by negative 9.8. Okay, delta y, putting that in your calculator, negative 9.8. Okay, we have 11.48 meters. Okay, this is now our delta y. Meaning, nung pinukol ng student yung bola dito at a velocity of 15 meters per second, umangat pa siya ng 11.48. But that's not our maximum height. Our maximum height would be 20 plus this value, 11.48. That would give you the maximum height of 31.48 meters. That is now your final answer for the maximum height.